So now we have to write a function that calculates the factorial for a given number, and we know that a factorial of a given number equals to num multiplied by num minus 1 multiplied by other numbers up until 2 multiplied by 1. So all the numbers multiplied one after the other from 1 up to given num. Okay, so that's the factorial of num. That's what it does. Okay, and you may see it in your math exams as something like this. So what we want to do is to write a function that will be able to calculate this factorial and also to add some functionality to our cool calculator that we are developing throughout this course. And it will be very similar to the previous recursive example that we've seen. We know that the function will return an integer type, right? Because an int multiplied by int and so on probably is going also to be an integer. So the type of the function is going to be int, the name of the function is going to be factorial, so int factorial, and this function will get just one number of an integer type, so int num. Okay, and now let's specify what this function does. So we talked about in one of our previous sections that a factorial can be found just by using an iterative approach, just by using some for loops or while loops, and we can find the factorial. And now what we want to do is to find it in some recursive manner. So what will be the first step? The first step we said is that we need to find what is the recursive call, what is the rule, what is the similarity, how can we divide the problem, the factorial of num, to some sub-problems. And one of the ways that we can see here that will help us is that we can see that the factorial of num equals to num, right, multiplied by what? Multiplied by all of this, and all of this part is simply a factorial of num minus 1. So that's just a simple math and some rules that we can see here. We know that a factorial is the multiplication of 1 by 2 by whatever comes next up until a given number, and in this case it's up until num minus 1. So this part equals to this part, and we know that thanks to that, we know that a factorial of a given number, this bigger problem, equals just to num multiplied by this kind of sub-problem. So that will be our recursive function call. So the function will return, right? We know that a factorial of num equals to num multiplied by factorial of num minus 1, so we just copy it here. So num multiplied by a factorial of num minus 1. And as previously, if we use some number here, right? If we use, let's say, int num equals to 3, and we call this function, okay, and we will create a variable called result equals to factorial of 3 of num, okay, of num, and we want to print out the result, so result equals to %d, and we specify the result here, we specify it like this. And we know that if we will build and run it now, we will see that the program also gets stuck, and the reason for that is because there is no stopping condition, there is no base case. The function is going to call itself over and over again, also for negative numbers, because nothing stops that, and that's definitely something that you don't want. You want to stop your recursive calls once you know the base case. And what will be the base case in this example? Basically, if we take a look, we know that a factorial of 3 is 1 multiplied by 2 multiplied by 3, and of 2 is 1 multiplied by 2, and we know that a factorial of 1 is simply 1, okay? We do not need to multiply it by anything else. So the stopping condition will be, let's just make sure we can use if num equals to 1, then return 1. So that's the stopping condition, and that's only valid, okay? Basically, we said it in the previous video, but that's only valid if we assume that all the numbers will be positive. So if one of the numbers will be negative, we also want to kind of stop this function, okay? So if by mistake the user, the function that calls this factorial, gives here a negative number, if we use this condition in this way, we just check if num equals to 1, and the user specified, for example, -5, then this condition will never happen, and we are going to get into an infinite recursive calls. So it's probably going even to be better to specify here if num is less or equals than 1, then return 1. So in this case, we are going to see what happens. So let's just go over this code line by line. And what we can see here is simply, first of all, we create num equals to 3. Okay, we can just initialize it like I've done here, or we can read this number from the user, it doesn't matter. So let's see what we do here in line 19. We call the function factorial for 3. So function factorial, that's the first time we call it factorial for 3. And this function, what it does, it returns right to this result. It assigns the result the returned result into this result variable. So it returns 3, right, because num equals to 3, multiplied by factorial of 2. But we cannot still return this result because we haven't found out this factorial of 2. There is a recursive call. So now we need to find what is the returned result for factorial of 2, and we can say that the result is return 2, right, because factorial of 2 is num equals to 2, it's just 2 multiplied by factorial of 1. Okay, so now we know that we are going to call another instance of this function, so we are going to call factorial of 1. So factorial of 1, we know how to find the result for factorial of 1 because it's trivial and it meets our base case, our stopping condition. So factorial of 1 simply returns 1 and it does not make any further recursive calls. So return 1, okay, so return 1, and we know that this one, okay, this function, this factorial 1 returned 1. So instead of this factorial 1 here, we can specify that the result here is going to be 1, and thus we can calculate the factorial of 2, which will be just 2, right? 2 multiplied by 1, and instead of factorial 2, we build our way up, and instead of this value here, we will specify just 2. And now we know that this factorial 3 can return a final result, which is the multiplication of 3 by 2, which is a total of 6, right? And this function, this factorial for 3, that's how we called it, factorial for 3, because num here equals to 3. So we see the result of 6 instead of this line. So the result is 6, and we can print it out to the screen. So that's how you do recursive calls and solve the factorial question or problem in a recursive manner. And if we build and run it, let's just make sure that everything works here. So we can see that the result is 6, and if we modify that a little bit to, let's say, 5, and we expect that it will be 120. Yeah, that's the factorial of 5, meaning 1 multiplied by 2 multiplied by 3, and then you just take and multiply it by 4 and 5, and you know that 6 multiplied by 4 will give you 24, and if you multiply it by 5, it will give you 120. So this is it for this video, guys. It was very similar to our previous example that we've solved together, and now I think you're ready to move on to some challenges that I suggest and really recommend you doing on your own, trying them, and only then to see the solutions. And as always, guys, thank you so much for watching. Continue in your progress, study more, practice makes progress, and I'll see you in the next video. Bye.